and thereafter we are going to work out the area of the shaded region. Whenever you are working out area of a sector, when you are given the angle in radians, you need to remember that area is a half r squared theta. And whenever you are working out arc length, you need to remember that the formula is r, which is r is the radius times theta, which is the angle in radians. Now, for instance, suppose you are given a question, a sector is given like this. This is a very common question that you're gonna find. That if you want to work out the area of this sector, you are going to apply this formula, area of the sector, whereby this angle is actually theta, and this represents the radius, and this represents the radius. So that's something that you need to remember. Any given point, you are given area of a sector like this. But now suppose this part is subdivided, in that you are expected to work out the area of the shaded part. You need to remember that this part that we have here is actually a triangle, and this part that we have meant. So meaning that for you to work out the area of a segment, you need to work out the area of the entire sector, and then you subtract the area of the triangle, so that you can be able to remain with this part that is shaded here. So we can say, therefore, area of segment is going to be given by what? Is given by area of sector minus area of triangle, right? For you to work out the area of the segment, you need to work out the area of the sector, then you subtract the area of the triangle. Area of a sector is a half r squared theta. Area of a sector is a half r squared theta, minus area of a triangle is a half r squared sine theta. Where are we getting that from? Remember, area of a triangle is going to be a half AB sine theta over this shape. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload further tutorials, you'll be notified. Proflan YouTube channel is a place whereby you can be able to find matters physics and math for both IGCSE and taking Cambridge, you are taking Edexcel. This is your place, because you're gonna get all the tutorials involving the two subject, math and physics, IGCSE and A level, so you can be able to learn and ace your grade. So now, in order to find the perimeter of this shaded region, we need to know what this arc length is. We need to is length S, so we can be able to find it in order to work out the perimeter. Number two, we need to know what, because this radius, circle center O had a radius of 6 centimeters. The radius was given as 6 centimeters. So which means that we have all the right reserved for us in order to work out this question, because we need to know to find here, right? We need to find this angle at this given point. How are we going to find this angle here? Is the fact that we're going to use the property that a radius, this part is also 6, is going to form 90 degrees with the tangent AB. So which means that this angle on this side, we can call it angle beta. We can be able to find it, and then it will enable us find this other angle on this side. So before we look into that, let us find angle beta. And since this angle is opposite to this side and adjacent to 6, so we can now say tan beta is equals to opposite over adjacent. So this is going to be tan beta. Beta is just a symbol to represent an angle like theta. We are going to say opposite is 8 over adjacent, which is 6. So which means that beta is going to be equal to the tan inverse of 8 over 6. So if we work out this, let's see what we are able to get. We are going to substitute this 8 and this here 8 into the formula. In order to work it out, remember we're going to say this is a tan inverse of 8 over 6. If you work it out using your calculator, you're gonna get the angle in radians. This value is 0.93. So we are going to say this is 0.93 radians. So which will mean that once we have this as 0.93, we can be able to work out the value of this angle on this other side here. Because this is a straight line, then we can say now this is going to be our angle theta. So theta is going to be pi, which is 180 straight line, minus 0.93. If we work it out, this is pi minus the answer, we're going to get 2.21. So this is 2.21 radians. So the angle that we have at this given point is 2.21 radians. So meaning that for us to find the arc length, we can be able to apply the formula. Arc length S is going to be R theta, so which is going to be 6 times 2.21. If we work it out, I'm going to put this in the calculator, then this is going to be 6 times 2.21, which translates to 13.26 centimeters. That is now this particular part. So next we need to know what is the length of AO. Remember, this is a point, so we can be able to use Pythagoras theorem in order to work out AO. So we can say AO is equal to the square root of, this is a shorter side, this is a shorter side, so AO is a hypotenuse, so we're going to say this is going to be 6 squared plus 8 squared, which is equal to the square root of 36 plus 64, which is equivalent to 100. Square root is actually 10 centimeters. The square root of 100 is 10, so meaning that this dimension here is given actually as 10 centimeters here. But for us to find perimeter, you need to remember that perimeter is distance or round. So meaning that in order to work out this perimeter, we're going to say perimeter is going to be this part, we got it down up here, which is 13.26 plus this part 8 centimeters plus 10 centimeters, then plus 6, because now up AO is 10 plus 6, which is the radius, plus 6 at this given point. Let's see what we are going to get. So that is actually 13 plus 8 plus 6, then plus 10. I'm getting my value as 37.26. This is 37.26 centimeters as the perimeter. Okay, now once we have this perimeter, the next question of interest about the area of shaded region. Now, in order to work out the area of this shaded region here, I'll work out the area of the right angle triangle, then add the area of this particular sector I have at this given point. So I'll add the area of the triangle, then I add the area of the sector. But remember, area of the triangle is going to be, this is a half base times height, because this is a base and this is the height. We have 90 degrees at this point. We're going to say a half base times height plus, I'll work out the area of this sector that we have in this part. The angle, we had gotten 2.21, so we're going to have a half r squared theta. So I'll say a half times 8 times 6. I'll work out that, and then I'll say a half times 6 squared, because the radius of this sector is 6, then times the angle which is 21, rather the times the angle which is 2.21. Then I'll enclose like that so that we can put that information in the calculator. So I'll say this is 1/2 times 8 times 6. I'll close the bracket, then plus open bracket 1/2 multiplied to 6 squared multiplied to 2.21. So I'm going to get my answer correct to 4 significant figures. My answer is actually 63.78. So the answer here is equals to 63.78 centimeter square. So basically, that's what you're supposed to do in order to work out questions like this, right? If you are new to Proflearn YouTube channel, consider subscribing so that anytime I'm going to upload a tutorial, you'll be notified. In this question here, we are supposed to work out the perimeter and the area of the shaded region. The information that was provided in this question is that O is the center of this circle. So O represents the center of this circle. So you can say this is a circle of center O, and the radius of this circle is 10 centimeters. AB is 15 centimeters. DC is 10 centimeters. So how are we going to work out this question in order to work out the perimeter of the shaded region and the area of the shaded part? So for us to work out this question, the first thing that we need to identify is that we can be able to join OB and also join OA like that. So since we are told that the radius of this circle is 10 centimeters, so we can say this is actually 10 centimeters and this point is 10 centimeters because both of them are representing the radius. So if we drop a perpendicular right from this given point, if we drop a perpendicular, let me just try to draw a perpendicular here. If we draw a perpendicular right from this given point here, we are going to have 90 degrees at this point, so that this is going to enable us work out the size of this angle. Then if we know the size of this angle here, we can multiply by 2 so that we can be able to get the size of angle A or B. So that's what we're going to do so that we can be able to work out this length here, and also we're going to find this length. Then because we will be able to work also the circumference of this circle so that we can be able to subtract and get what this part is. So first, let's find this angle theta. Angle theta here, let me just write it properly. Angle theta is going to be what? We have this 10, then if this is 15, the entire of it, this line from the center is going to subdivide this into 2 halves. This is going to be 7.5 and this is going to be 7.5 because a perpendicular line to the chord from the center of the circle is going to subdivide this chord AB into 2 equal halves. All right, so we're going to extract this triangle, right angle triangle here. This is 10 centimeters.